Good day, everyone, especially to the Dean of CEAID and the panelists. We are basically A4A students who created a thesis titled Gregg Shorthand Translator using optical character recognition. Statement of the problem. Learning shorthand is like learning a new foreign language. This means that it requires extensive learning and practice. The art of shorthand is a skill that can be quite tedious. And for this reason, researchers created a system that would address this problem particularly. The researchers aim to answer these questions. First is how to make a translator for people who cannot read Gregg's shorthand, how to implement shorthand to longhand translation, how to implement longhand to shorthand translation, how to incorporate the speech input feature for the longhand to shorthand translation, how to incorporate a speech output feature for the shorthand to longhand translation, how accurate will the system be in terms of shorthand to longhand translation, and how fast will the system be in translating in terms of shorthand to longhand translation. Now to clear things up, shorthand refers to the Gregg shorthand image, and longhand refers to the English text or word. Rationale. Shorthand is a system for rapid writing that uses symbols or abbreviations for letters, words, or phrases. Throughout history, shorthand has been written in systems based on orthography, phonetics, and arbitrary symbols, with the aim of improving the speed and brevity of writing compared to the conventional method of writing. Gregg shorthand, invented by John Robert Gregg in the late 19th century, is a writing system that utilizes curves, lines, hooks, and loops to deliver a handwriting speed of up to 200 words per minute. In the Philippines, the Gregg shorthand is still widely used in courtrooms and among journalists. It is one of the major subjects offered in higher education institutions in the Philippines, and one of it is Bohol Island State University. One such course that offers this subject is Bachelor of Science in Office Administration. Despite the advancement and modification of Gregg shorthand, students still have difficulty learning shorthand because, despite the years that have gone by, the method of teaching is still the same. For these reasons, the researchers created a system called the Gregg Shorthand Translator that addresses the problem by implementing OCR with a canine classifier that translates shorthand to longhand and vice versa. Literature background. Optical character recognition is the technique of classifying optical patterns included in a digital image that correlates to alphanumeric or other characters that are acquired by optical means, typically a scanner or a camera. In OCR, numerous algorithms can be used, and one such algorithm is the k-nearest neighbor. Some studies aim to investigate the mechanism behind OCR by employing the k-nearest neighbor algorithm, one of the most influential machine learning algorithms. We have existing web and mobile applications, namely Gregg Shorthand Translator, and Gregg Generator. For Greggy, it is said to be able to translate Gregg shorthand to longhand and vice versa, but the only record of its existence is in a blog. This means that there is no downloadable file that can be seen anywhere on the internet. Second one is Gregg Shorthand Translator. It is still in operation, and it can translate longhand to a variety of shorthand scripts, but it does not offer a reverse translation option which utilizes OCR. Lastly, we have Gregg Generator. Its only record of existence is in an online open forum. It was said to be operating about a few years ago, but when we tried to visit the link, it is no longer hosted in the cloud. And it is also a text to Gregg shorthand generator, but as I said earlier, it can no longer be found. Methodology. The researchers employed an experimental approach in conducting the study, and it is reflected in Figure 1, the procedure that we followed. And the first one is data gathering. Since there are no data set available for us to use, we gather data from these old students, and this amounted to 1,029 words, which is the scope of the system, and 42,491 total samples. Next was data capturing, processing of training data, which also included rotation of the original samples collected, the original shorthand images collected. And this amounted to 3,679,403 because images were dated from negative 45 to positive 45 degree, incrementing by 1 degree. Next was the training and testing of the Canaan classifier, the addition of longhand to shorthand translation feature, the addition of speech to text and text to speech features, development of the user interface, testing the desktop app, and performance of Gregg Shorthand Translator. Figure 2 reflects how the system works. So we've got a main window when the user opens the desktop application, and the user can choose between shorthand to longhand or longhand to shorthand translation. If the user chooses the shorthand to longhand translation, well, of course, a corresponding window pops up, and then it receives an image input, performs the translation, and outputs the longhand text as well as the speech. On the other hand, if the user chooses the longhand to shorthand translation, this corresponding window pops up, and if it is not connected to the internet, the user can only input a text on the text field. If it is connected to the internet, then the user can access the speech input feature. And once that speech input feature has been received by the system, this is then translated to text, and that text is used for the longhand to shorthand translation, which is basically just wording. And the corresponding image is then output to the user interface, and the user can opt to go back to the main window or repeat the same translation process. And for table 1, this is what we use in tabulating the results of the tests, and we conducted 2,058 tests, which means that we had 2 images per word for testing. And for the accuracy, the formula we used is the following: the number of correct translations divided by the number of testing data times 100, and for the average runtime, it's basically just the sum of all runtime speeds divided by the number of trials. Findings, conclusions, and recommendations. So we have here our user manual. This is the cover page. This covers an overview of the application and the system requirements as well as its installation. And we have here the second page of our user manual, which covers how to use the application. We have images of the user interface and how to use it. And we have here the results of the testing. So for the accuracy testing results, as you can see, we have tested 2,008 data, and the number of correct translations are 1,271 out of 2,058, and the accuracy is 61.76%. As for the runtime speed, it averaged to 67.33 seconds. The researchers were able to design and implement a Gregg Shorthand Translator using OCR, implementing both shorthand to longhand translation and longhand to shorthand translation. The researchers were also able to implement a speech input feature for the longhand to shorthand translation, as well as a speech output feature for the shorthand to longhand translation. Future researchers are recommended to increase the scope and accuracy of the system by gathering more data. They can also host the Canaan classifier backend on a remote server, along with a web or mobile application for portability. It is also recommended for storing input shorthand images in a database for further training and exploring other machine learning algorithms, because so far the only algorithms that has been explored in creating Gregg shorthand translator systems are CNN and Canaan. And this time, let's see a video demonstration on how we use the application. Here we have our application called Lightline, and before opening it, let us make sure that our camera is connected to our desktop or laptop. As you can see, we've got a main window. Let's go first to the shorthand to longhand translation. Click the camera button to start the camera. Now let's click the shutter button to capture an image. Once that's done, click Translate and wait for the application to process the translation.
Engine.
As you can see, we have the result, and to check if that is correct, let us use our longhand to shorthand translator. And yes, we've got it correctly. Let's take another example. Let's still follow the same process as we did earlier.
Doctor.
And we've got our output. Let's check it again. And here we have it. Let's do a few more examples.
Other.
Let's check it again. Let's have a last one.
Jump.
Let's check it again. Now let's try our speech input feature. Ability. And that's it.